So let's start with sample proportions because that's actually, more close. Well, others, I shouldn't say more, but very closely related to our real life, right? Because, for example, we say that there will be about 65% people supporting a certain presidential candidates, right? So let's denote the sample proportion as P, right? That's our observation. Right? We observe from a sample that 45, I don't know, right? 65 or any kind of percentage of people from the sample will support certain candidates, and we surveyed N people. Okay, so the 95% confidence interval, well, we're using 95 because this is the most commonly used confidence interval, right? So the 95% confidence interval will be the sample proportion minus or plus the z-score associated with the probability of 0.95, which is 2, right? We just said that, times this whole thing, which will be our standard error for proportion. Because the general formula for confidence interval is point estimation, or let's use x, right? The point estimation could be sample mean, could be sample proportion, plus or minus z, right? Whose value is to be chosen, times the standard deviation or standard error of the point estimate. Because now we're talking about proportion, right? So we, replace p here for x, and then we need the formula to calculate the standard deviation for proportion, sample proportion. It turns out that this is how we calculate standard deviation for sample proportion. It will p multiplied by 1 minus p divided by sample size, and we take the square root. Okay? So, right, so this expression is exactly the standard error or margin of error, right? That's exactly the sort of question I asked you at the start of yesterday's class, right? What does it mean to say that the survey has a X% of margin of error, right? Margin of error is essentially the standard error um, for the estimated proportions. Okay, so now we can sort of start to answer a more concrete question. For example, your boss asked you, well, from a sample of 500 Honolulu citizens, 60% of them favor gun control, right? Well, we know that we can sort of make a guess based on the sample proportion. Then we can say, well, then for the entire population of Honolulu citizens, then approximately 60%, again, probably 60% of all Honolulu citizens will also favor gun control. But then we can't be certain, right? We only said that probably, based on sample information, that 60% of all Honolulu citizens are favoring gun control. But how do we quantify this probably, right? Well, we said that we're going to use confidence intervals. So the boss will ask you, well, then give me an interval estimation, right? How likely um, this population proportion are going to fluctuate, right? So what's the range, in other words, of fluctuation of your guess? It could be 60. I know it's a good guess, um, but you know, what's the extent? What is the extent to which that the true proportion, right? The proportion from the population will fluctuate around 60%, right? Okay, so what do we do? Right? Easy. This is our question, and this is our formula, right? And then we know that P is 0.54. That's from the question. And is 500, and we know that from the table that we in the previous slides, right? The z score for 90 for the probability level of 95% is 2. So this guy here, the standard error or margin of error for this particular sample proportion will be what is it? Okay, it will be 0.54 times 1 minus 0.54 divided by the sample size, which is 500. Okay, so we can calculate this together. It will be 0.54 times 0.46, right? You will be, if I'm doing this correctly, 0.2484 divided by 500. Okay, divided by 500. And we take the square root of that value, right? Don't forget about that step. It will be, I think, 0.02. Okay? And then we ask ourselves, what is the 95% confidence interval, right? Given this finding here. So, whoops. Right? We're doing this correctly. So the standard deviation, this guy here, is 0.022. Well, 0.02. Close enough. So now we can write out the whole thing, right? It will be 0.54 plus or minus. We know Z 95% is 2, right? 2 times 0.02. So you'll be 0.54 times plus or minus 0.04. So it will be interval 0.50 or 0.58. Boom. That's our 95% confidence interval for this sample proportion. That means, sure, we can make a single point estimation saying that based on the sample, there will be about 54% of all Honolulu citizens, right? Not just 500, because we're extrapolating this information to the entire population. So we can say that about 0.54% of all Honolulu citizens will be favoring gun control, but this percentage, the true percentage, might fluctuate around this percentage from 0.50 to 0.58. And we're 95% confident that the true proportion, the true population proportion, will be within this interval. That means, if we draw 100 samples from the population, there will be exactly 95 samples that will yield a proportion that's between 0.5 and 0.58. 0.50 and 0.58. There will be about 5 samples that will yield a proportion that's either smaller than 0.5 or larger than 0.58. 0.50 or 0.58. Okay, so again, right, this is the meaning of 95% confidence interval. So if this is our 95% confidence interval, it means if we draw 100 samples from the population, right, all Honolulu citizens, there will be exactly 95 samples that will yield the proportion, which would not be exactly 5.4. It could be, doesn't have to be, but the sample proportions from these 95 samples will be greater than 0.50, smaller than 0.58, and there will be about 5 of them that will yield proportions that's beyond this interval. And that's why we said we're not 100% confident that, this interval will include the population proportion, right? We're given we're given some, a room for possible errors, but in most cases, 95% confidence level is good enough. Okay. Okay, so this, to be exact, right? If we use 0.022, right, the confidence level will become 0.496 to 0.584. Okay, so this is sort of approximation, but this will be the exact confidence levels. Okay, so of course, right, the confidence level will change each time you draw a new sample because we know from the formula, right? Formula Ci equals to, well, we're using proportion here. So, right, so Z 95% SE, right? So we know that the confidence interval for sample proportions will equal to the sample proportion minus or plus the z of a certain confidence level timed or multiplied by the standard error of the sample proportion, right? So we know that this guy, sample standard deviation or standard error of the sample proportion equals to p times 1 minus p divided by n, right? So that means if we know sample proportion, then we know it's standard error. But of course, each time you draw a new sample, right, this p will likely to be different. It could be the same, but likely will be different, right? So because the confidence interval, in other words, will depend on the proportion, right? Um, we have, we can now interpret the meaning of this, 95% confidence interval, right? This is exactly what we said before, right? This confidence level will change depending on p, and that's why, from the another way to understand it is because each time we'll have a new confidence, right? New confidence interval. Then these, if we draw a sample, if we draw 100 samples, that means we'll have 100 confidence intervals, right? And then this 100 confidence intervals, from these 100 confidence intervals, 95 of them would include the population proportion, right? And about 5 of them would not include the true or the population proportion, the proportion to be estimated. Okay, and only about 5 of them would not include the true population proportion. Okay, so that's another way to understand this 95% confidence interval. Okay. Okay, so here is the confidence interval that we just calculated from this question, right? So, let's, to be exact here, is from 0.496 to 0.584. That means the population or true proportion of support gun control will be any value between the lower bound and upper bound. Okay, it will be some value, right, between these two within this interval. Okay, so now my question is, if this is our confidence interval, 195% confidence interval, right? And if the meaning of it is that the true proportion of support gun control is any value, or any value between these two values, can we say that the majority of Honolulu citizens will favor gun control at a 95% confidence interval? Can we say that? Can we say that we'll have a clear majority here? You say, wait a minute, we should have a clear majority here because, hey, we have a sample proportion of 54%. But wait a minute, this is just one sample, right? We're saying here, if we draw more samples, let's say 100 samples, 59 of them will range, the proportion from 95 samples will range from 0.496 to 0.584, right? In other words, there will be a range of variation here. That means it's not, it could be 54% exactly, but it doesn't have to be. Okay? It could be any value, right? The proportion, the population proportion. We're not talking about, right, the sample here. We're talking about the population proportion here. So the question is, well, if this is the proportion interval, confidence interval for population proportion, that means any population proportion could be, you know, anywhere between these two values. Then can we say that the majority of Honolulu citizens will favor gun control at a 95% confidence interval? Okay. Well, you should pause here to think about it for a while before listening to my explanation. The answer is no, right? And the reason to say no is because this confidence interval includes 50%, or includes 0.5, right? 0.5 is the split or the threshold for majority, right? If you have exactly 50% of Honolulu citizens support gun control, that means you will have another half of the population that is against gun control. Then you don't have a clear majority. Even worse, if the true population proportion is not even 0.5, right? Because it could be any value that's greater than this, smaller than this. The true population proportion could be 0.497. And if that's the case, this is actually a minority, right? By no means this will be the majority. Okay? And that's why we should say no, because exactly the interval includes 0.5, right? So in other words, the sample proportion, 0.54 is not meaningfully different from 0.5 at a 95% level, right? There's a difference. Of course, these two values are different, but statistically they're the same because this difference of about 0.04 could just because of chance, right? These two values are not, meaningfully different because the interval that we calculated, the 95% confidence interval that we calculated for this point estimation includes 0.50, and therefore these two values are not meaningfully different. In fact, right, if this is the confidence interval for this sample proportion, that means 0.54 would not be meaningfully different from any values that fall in this interval, including 0.50. Okay? All right, so now let's repeat this exercise from a sample of 500 Honolulu citizens. 56%, now it's not 54, but 56% of this 500 people favor gun control. Now, what is the 95% confidence interval of the sample proportion? Okay, so we can do the calculation together. So CI will be equal to, right, the point estimation for proportion plus or minus the z value for 95% confidence interval times its standard deviation, standard error. Okay, so this is our formula here, and we know that proportion, the p here is what? P here is 0.56, and we know that this guy, or the z value for 95% confidence interval, would be 2, right? Now, our only problem is to solve standard error for proportion, and we know the formula, right? So this will be 0.56 plus minus 2 times 0.56 times 1 minus 0.56 divided by sample size is 500. Okay? And this will equal to 0.56 plus minus 2 minus times. So if we do the calculation for this, square root thing here, right? So it will be, let me do this together. Or let us do this together. So it will be 0.56 times 1 minus 0.56. It will be 0.44, I believe. Okay. That will be 0.2464 divided by 500, which is a very small value, but don't forget to take the square root of it. So it will be about if I did this correctly, it will be again 0.022, right? So it will be 0.56 plus minus 0.044. Okay, so 0.044 plus 0.56 will be, so the interval will be 0.64. Right, this is 0.56 plus 0.044. That will give us 0.604. But then what is 0.56 minus 0.044? That will be, we have 0.516. So this should be our confidence interval. Let's check. Exactly, right? So the standard error is still 0.022, but now because we have a different proportion here, so the confidence proportion will also be different. So this time it's 0.516 to 0.64. Now let me ask you, if this is the confidence interval for the sample proportion here, can we say that the majority of the Honolulu population will favor gun control? Is there a majority? Is there a majority now? The answer should be yes. Now there is a majority. That's because despite the fluctuation around 0.56 from 0.516 to 0.64, all possible values, right, at the 95% confidence interval will be greater than 0.50, right? It will be greater than half, right? The smallest value here is 0.516, which is still greater than 0.05. That means even if we take this value as our smallest possible sample proportion, right, because of fluctuation, right, it will still be a clear majority, right? Not by a huge margin, but still is a clear majority. So that means, right, statistically speaking, this value, 0.56, will be significantly different or meaningfully different from 0.50 at 95% level. Actually, all values within this confidence level, because this interval does not include 0.50, all values within this confidence level interval will be meaningfully different from 0.50. Okay, so that means the majority of Honolulu citizens favor gun control because the smallest possible value, the smallest possible population proportion is a clear majority. So we're pretty sure, right? Or 95% confident that the majority of Honolulu citizens favor gun control.